Before we start, let's recall what is a sequence. So, a sequence is a set of numbers that follows a particular pattern. We call each number in a sequence a term. Now, how about geometric sequence? Let's have an example first. We have 2, 4, 8, 16, 32, 64, and so on and so forth. Another example of a sequence is 243, 81, 27, 9, 3, 1, and so on and so forth. Now, how about geometric sequence? What's the difference of geometric to our last topic, arithmetic sequence? So let's see. Geometric sequence is a sequence where each term is found by multiplying the same value from one term to the next. In arithmetic, we add. In geometric, we multiply. Okay? We call this value common ratio. In arithmetic, common difference. In geometric, we have common ratio, denoted as R. Okay, so let's continue. Let's have an example. Example, we have 2, 4, 8, 16, 32, 64, and so on and so forth. Now, notice that 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 will give us 32, and 32 times 2, we have 64, and so on and so forth. Therefore, we can say that the common ratio of this geometric sequence, is 2. Now, since the sequence have a common ratio, we call this sequence a geometric sequence. Okay? So, how about the next example? 243, 81, 27, 9, 3, 1, and so on and so forth. Notice that 243 times 1/3, because 243 divided by 3 will give us 81. So 243 times 1/3 will give us 81. 81 times 1/3 is equals to 27. 27 times 1/3, or 27 divided by 3, will give us 9. 9 times 1/3, or 9 divided by 3, will give us 3. And 3 times 1/3 will give us 1, and so on and so forth. Therefore, we can say that the common ratio of this sequence is 1/3. Now, since the sequence have a common ratio, therefore, the sequence 243, 81 up to 1 is what we call a geometric sequence. Now, another way to compute for this 1/3 and 2, or the common ratio, is by using this formula. So, what is this formula? The formula for the common ratio is equals to R is equals to A sub n all over A sub n minus 1, where n is greater than 1. So, since n is greater than 1, the smallest value for n is equals to 2. Now, if we replace n is equals to 2, this becomes a sub 2 all over a sub 2 minus 1, or simply a sub 2 over a sub 1, second term over the first term. If we let n is equals to 3, this becomes a sub 3 over a sub 2, third term over second term. It can be fourth term over third term, fifth term over fourth term, and so on and so forth. Now, let's try. We have second term over the first term. 4 divided by 2 will give us 2. Third term over second term. 8 divided by 4 will give us 2 also. 16 over 8, fourth divided by third will give us 2, and so on and so forth. Therefore, we can say that the common ratio is equivalent to 2. Let's try to find the common ratio of the second sequence. we have r is equals to 81 over 243, or simply 1/3, because 243 is equals to 3 times 81. Now, you can use also calculators to verify your answer. So let's use calculator. Oops. 81 divided by 243 is equals to, there you go, this is 1/3. So the next one, third term over the second term, 27 over 81 is also 1/3. 9 over 27 is also 1/3. 3 over 9 is also 1/3. 1 over 3 is absolutely 1/3, and so on and so forth. Now, can you tell if the next two sequences are geometric or not? And if yes, can you get its common ratio? Let's see. The first one, 2, -8, 32, -128, 512, -2048, and so on and so forth. Letter B. 1, 3, 5, 7, 9, 11, 13, and so on and so forth. Feel free to pause this video to have more time. Let's have the solution. For letter A, 2, -8, 32, -128, 512, -2048. If your answer is a geometric sequence, well, you're correct. So let's see why. Second term divided by the first term, -8 divided by 2 will give us -4. Third term divided by the second term, 32 divided by -8 is also -4. And -128 divided by 32, fourth term divided by the third term, is also -4. Since it has a common difference, therefore, this sequence is a geometric sequence. Letter B, number 2. 1, 3, 5, 7, 9, 11, 13, and so on and so forth. Now, if your answer is not a geometric sequence, well, congratulations, you are correct. So let's see why. If we take the common ratio, second term divided by the first term, 3 divided by 1 will give us 3. 5 divided by 3, third term divided by the second term is 5 divided by 3 is already 5 over 3. And then 7 over 5, or the fourth term divided by the third term, 7 divided by 5, simplify, is 7 over 5. Now, since 3 is not equal to 5 over 3, is not equal to 7 over 5, it is not a geometric sequence because it has no common